Question 9 is similar to question 6 in that we we'll find our answer by interpreting a graph. It's a question involving present value of an annuity, and present value is the amount that we start with before we start dispersing, before we start making payments, before we start taking payments from the annuity. And so as the payments are made, the amount that the annuity is worth is gradually decreasing. And so in this question, 40 equal payments of $400 exhaust the annuity, which means that there's nothing left at the end. And so if that is the case, and the present value is $12,000, what interest rate per compounding period is being paid? Now, we don't know what the compounding period is. We just know that there are 40 payments of $400 that decrease this annuity with a present value of $12,000. So here's our formula: present value equals payment times, in the numerator, 1 minus the quantity 1 plus I raised to the negative n, and in the denominator, that same I, that variable that we're looking for, the rate per compounding period. And so we then substitute all the values from the given in the question into the equation: present value 12,000, payment 400, rate per compound, or rather number of compounding periods 40. And we need to solve for I, and again, I is inside of the base of an exponential expression here, and it's in the denominator here, and so that's going to be beyond our means to solve, so we need to choose one of 4. I will supply 4 graphs. We'll choose the correct graph of 4 to interpret. And again, because it's a present value that is being exhausted after 40 payments, that tells us that this is a decreasing function. The 12,000 is a constant function, so that's going to be a straight line at 12,000, and we look for the graph of the function that is decreasing, and where they intersect is that rate per compounding period. So it looks like they intersect at about 1.5. You might say, oh no, it looks like they intersect at 1.495. Well, that'd be close, but 1.5 is close enough. 1.5 is a good enough estimate. We see the intersection, we find the intersection, and we follow that down to the x-axis and see that 1.5%, because x is given in percent, not decimal, is the solution. And again, as in the other graph, the y-axis is, these values are in thousands. So this is 8,000, 9,000, 10,000, 11,000, that's 12,000. So our rate per compounding period is 1.5%. And finally, in question 10, we're buying either a really small house or a house in a really rundown, crappy neighborhood, or maybe we're buying a fixer-upper. But it's our first house, and we're purchasing that for $96,000. Excuse me. And the mortgage company requires a down payment of 15%. Now, we're going to make a down payment of 20% to avoid paying mortgage insurance. You make a down payment of 15%, they're going to charge you mortgage insurance, but if we make a 20% down payment, they'll forego that. Now, they're offering a 30-year loan at 4.5% compounded monthly, And so we want to know how much our monthly payments are going to be if we put that 20% down. Well, 96,000 minus 20% of the 96,000 is the balance that we're going to finance. And 20% times 96,000 is 19,200. We subtract that from 96,000, and so the amount we're financing is $76,800. $76,800 is the present value of an annuity, and to pay that new annuity down to zero, this is the formula for the payments that we need right here. And so payments are our unknowns, so that goes without being filled in. The I is the rate, 4.5% per compounding period, which is 12, since there are monthly payments. So that's in our numerator, 0.045 divided by 12. It's also here in the denominator in this spot right here. I is equal to 0.045 divided by 12. And then the N is equal to the M. M is in Mary, number of compounding periods per year, which is 12, because we're compounding monthly, times the number of years, which is T, and that's 30 years. And so we fill all of this in, and if we enter it all in correctly, then we will come up with payments of $389.13. Alright, so not all of these formulas have everything filled in, completely explicitly, like N. N is equal to the rate divided by the number of compounding periods per year. And so you should go to the beginning of the chapter, or at least section 3.2, and write down things like that. R over M is equal to I. You can also find these formulas in the handout that I gave you for section 3.2. So that's, let's scroll to the end, even though the print version of this is available online. So that's everything, unless there's a bonus question. That's everything we will definitely be asked on this third exam. If you have any questions, give me write me an email, or send me a text to 464-5781. All right, good luck, everybody.